Alright, so this is lesson 8.3, so we're graphing quadratics in both vertex and standard form. So quick review, we have y equals a x minus h quantity squared plus k. This is vertex form because our vertex is easily identified by the h and the k as the point. And then this a will tell us whether or not we are shrinking, stretching, or reflecting. So we could stretch or shrink, and we can also reflect. Standard form is y equals ax squared plus bx plus c. So we are going to start incorporating this middle term for our equations today. Alright, so our first example is going to be y equals 2 times x plus 4 quantity squared minus 6. So we want to come and say, okay, well my parent function is y equals x squared. So I have three different things that's going on that's changing my parent function. So first I'm going to look and say, okay, well I'm stretching it by 2. I'm not reflecting it because it's positive. And then I can easily identify that my vertex is -4, -6. So we always go the opposite of what's inside here, and we take the same for this. So the same is what I'm referring to. So my vertex is -4, -6. So that means that we are in the third quadrant, and we are opening up. So -4, -6. And put my point there. And so that's my vertex. And then from this, I can go right one, up one, except for we're stretching by 2. So instead of going right one, up one, I'm going to go right one, up 2. And that'll be my point. And I can reflect that across. My axis of symmetry is what goes straight down the middle. And then normally 2 squared would give us 4, but I'm doubling it. Whoops. So I'm going to go right 2 and then up 8. Okay, so 2, 4, 6, 8. And then reflect that across the y-axis. And I can slowly draw my lines and connect the points. And that's it for the first example. Our second example is y equals -1/4 parentheses x minus 5 quantity squared plus 7. So again, I want to see what did I change in the parent function. And we have 3 things that we changed. So I am reflecting and shrinking, and my vertex is 5, 7. So we are reflecting and shrinking. And we're shrinking by 1/4. And then my vertex is 5, 7. So 5, 7, that's in the first quadrant. And we are going down, so I'm going to draw my graph like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So 5, 7, that's my vertex. but I want to go back to the parent function as much as I can. So I'm going to see if I can factor this. So are there two numbers that multiply to 7 but add to -8? Yeah, -1 and -7. Those would add to -8. So if we set this equal to 0, we can solve for our x-intercepts by saying, okay, well, what would make this factor 0, and what would make this factor 0? So if this was a 1, then that would make that 0, and if this was a 7. So notice I'm not putting parentheses around this like that because I'm not listing a point, I'm listing two x-intercepts. Okay, so then from that I can graph so we have 1 and 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6. Oh, 7's way up here for my y-intercept. So this is kind of a tall graph. The next thing we're going to want to try to find is our axis of symmetry. So once we find our axis of symmetry, then that can help us find our vertex. Our axis of symmetry will be halfway between these 2 points. So I can kind of count to the middle and say, okay, we have 1, 2, 3, 4, 5, 6 between. If I go half that, then that's right between, so that's 3 on each side. So I know that my axis of symmetry is x equals 1, 2, 3, 4, and that my vertex lies on the axis of symmetry. So if I use the equation up above to plug in, then I can solve for the y value of my vertex. So 4 squared is 16, 8 minus 4 is 32, and then plus 7. So y equals -16 plus 7, y equals -9. So my vertex is 4, -9. The 4 comes from the axis of symmetry, and the 9 comes from plugging in x value for the axis of symmetry. So that x is going to be way down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can also look and see, I did not stretch this because my leading coefficient up here is a 1. So I can use the parent function to go right 1 up 1. Oops, let's change. Left 1 up 1. Right 2 up 4, left 2 up 4. And now I have this overall shape. I'm going to do the best I can to connect my points with as straight a line as possible. And that's the graph. So it's a lot more detailed because we had to find our y-intercept, our x-intercept, our axis of symmetry, and then use that to find our vertex. So first, second, third, and fourth step. So let's do one more, and then we will be done for this note. So we've got y equals 3x squared minus 6x. Okay, so we want to say, what's our y-intercept? Okay, well, there's nothing actually out here, so I'm just going to put a +0 so that I can see that, oh, that's why it's a 0. Okay, and then can we factor this equation? Yeah, we have a GCF, so if we factor that out, then we get 3x times x minus 2. And that helps me find my x-intercepts, because if I set it equal to 0, well, that would be 0 and that would be 2. So that's 0 and 2. Again, I'm not putting a point down, I'm listing two values. Alright, so then we can draw our graph, and we are crossing at 0, 0 and at 2. So that graphs both of these. My axis of symmetry, we said, was right between the two, so there's only one thing that's right between them. So that means that my axis of symmetry is that x equals 1. Okay, well, I can plug that in. I'm actually going to plug it into this factored form. So it's a little bit easier to solve. So we get y equals 3 times 1 is 3, and 1 minus 2 is negative 1. So y equals negative 3. So that means that my vertex is 1, negative 3. And that's 1 comes from the axis of symmetry, and the negative 3 comes from plugging in the axis of symmetry. So we go to 1 and negative 3. Now this makes sense that it is this tall because I stretched it because of this leading coefficient of 3. I'm not going to put any other points on this because the graph would go way off the graph. That's it for today's lesson. Let me know if you have questions.